Hi, I would like to discuss about one of the major component from the nuclear power plant, that is RCP, Reactor Coolant Pump. As we all know that the reactor is the heart of a nuclear power plant. So we have to circulate the coolant through the reactor up to the steam generator. So for that forced circulation of coolant, we are using RCP. The RCP is simple a AC induction motor, that is squirrel cage induction motor. The capacity of this squirrel cage induction motor is about 10,000 HP in mechanical terms. So the required or the electric energy consumption of one RCP is about 7 megawatt. So there are four loops of primary circuit. In each primary circuit, there should be one RCP at least. This RCP individually, separately, or independently provides the forced circulation for a circuit, for a loop. So this for loop works together. So the four RCPs togetherly providing the forced circulation. For this squirrel cage induction motor, the required supply AC voltage commonly starts from 6.9 kilovolt to 13 kilovolt. That much AC supply is required. The main other concern is the frequency of the supply. In AC, all over the world, there is two standards in frequency level. One is 50 hertz and second one is 60 hertz. Depending upon this frequency, the speed of the RCP may vary. So for starting this RCP, we are using variable frequency drive. So we can easily start the motor or we can operate this motor in whether it is 50 hertz or 60 hertz. We can easily start the motor or we can operate. So this VFD provides the starting also. In RCP, the starting of the RCP, the speed may from 24% speed at starting, then it will increase gradually. That provided by the VFD drive. So we can coming back to the RCP. This reactor coolant pump, the motor side is we have already told that it's a squirrel cage induction motor. Other main parts is one is shaft that is connecting this motor to the pump. The pump, the impeller part that is creating the mechanical flow of the coolant. The construction, when we are going to, as you can see in the picture, when we are looking into the construction, the motor is situated on the top. In middle, the shaft, and in lower side, the impeller is rotating. It's the rotation is centrifugal. So the primary coolant is entering into the impeller and circulates and going out. This coolant, its name is coolant, but its temperature is about 300, above the 300 degrees to 350 degree, and the primary pressure boundary is about 150 bar or more than that. So the RCP should be maintain this primary pressure boundary, and it has to kept this much temperature also. Even though the temperature is high, the pressure is high, we have to keep the forced circulation throughout the RCP. So the construction is vertical single stage centrifugal pump, that is the RCP. The required supply is 6.9 kilovolt to 13.8 kilovolt AC. Frequency may 50 hertz or 60 hertz. The capacity is 10,000 HP. So the electrical energy consumption is about 7 megawatt for the case of one RCP. I have already told that there may be four RCPs. So I would like to concentrate on one topic again, that is in advanced reactors, especially I will say the AP1000. In AP1000, they are using the canned motor RCP. In that, they are eliminating, they are avoiding the use of shaft seals. So what is a shaft seal? So we have to cool the component, that is the RCP, for during the operation, even though the coolant is circulating through the pump at having more than 330 degrees Celsius of temperature and having the high pressure. So the RCP should be cooled. There, in normal case, we are providing air cooling, oil cooling for the RCP. So we also using the component water cooling system also. So there should be some type of shaft seal needed to isolate these two types of circulation of waters. One is coolant and another one is component cooling. In this canned motor RCP, there is no need of using this type of shaft seals. So more secure, having the advantages of more safety in the view of the construction, the canned motor RCP providing more safety features. So it's an advanced type of RCP. In canned motor RCP, you can see in the picture, it's also a vertical single stage centrifugal pump, but in position it's just inverted. So the impeller is at the top and the motor part is at the bottom. The shaft, there is no big shaft connection because it's a can. It's all covered, encapsulated within the case. In AP1000, there should be two this type of vertical single stage centrifugal canned motors. This provides the starting and also the protection for during the operation of this canned motor RCP. Now we can look into the another major part of this RCP, that is the instrumentation part for this RCP. In motor side, there are 9 numbers of RTD. What is an RTD? That is resistant temperature detector. This device, it's a passive device, it will provide the resistance value proportional to the temperature. It detects the temperature and the resistance value of this device will change accordingly to the temperature. There are 9 numbers of RTD for sensing the stator winding temperature. It's a crucial part of the motor. In this, 3 sensors are provided for each phase. So 3 into 3, 9 numbers of RTD sensors are provided for detecting the temperature of the stator winding. And for monitoring the speed, there are 2 numbers of speed monitoring also there. Furthermore, sensors for vibration. It's a major part of the instrumentation for surveilling or monitoring the vibration of this RCP, the motor side. There are provided sensors. The sensors using the feature piezoelectric effect, that sensing the vibration and will send the signals accordingly the RCP while operating. So these are the sensors in the side of the motor. One is the stator winding temperature sensor, speed monitoring sensor, and also the vibration sensors. These sensors are providing the signals as per the operation of this RCP. It's very important to survey for the surveillance as part of the safety of this RCP, providing the signals to send. Overall, what I have tried to explain is that RCP is a crucial part in the primary circuit of the nuclear power plant. There are advanced type of RCPs are available now. One of the example is the canned motor RCP. So the RCP are providing the forced circulation throughout the primary circuit of the nuclear power plant. This was an overview about the RCP, especially on the motor from an electrical engineering side. I know there are many more details to deep dive and explore in this topic. But now I would like to conclude my this presentation. Thank you for watching. Goodbye.